We have the tanks coming down, and then they're feeding this system. Okay, they go to the back of this header over here, this big blue header, and then they go through each pump, and each pump has a check valve and a gate valve, and then has a soft start. It's not a VFD; it's a soft start.
So there's no variable frequency or variable drive in any of it. It's either on or off. But
It's
they
on
just
or off.
soft stop.
Soft start, soft stop. Okay, and then we go to the discharge header right here, and then we're going out to the across the road, and there's some isolation valves uphill, downhill, HET, summit, and then our valve.
That's the 8-inch.
The what?
That's the 8-inch line that ties into.
Is it 8 or 6?
It's a line that goes up and down a hill.
I think it's 8.
I think it's
Yeah.
8. I think it's 8.
Yeah.
It's 8.
Anyway, so then we have two compressors, and they're parallel. They work independent. Well, he can tell you that. So we have two air compressors, and then we have from the air compressors, we have the air line goes to the hydro tank, and then from the controller, we're controlling each soft starter. We're monitoring the pressures, and the air compressors. We're monitoring everything. We're even monitoring the chlorine out there. So that's an overview. And then, Bart, if you want to do the hydro tank,
Sure.
we'll take over from there.
Let's step outside where the hydro tank is.
Boy, it's rumbling, but I'm kind of slow.
Oh.
Okay, this is your hydromatic tank. It is a 4,000 gallon tank. It is designed and rated for 250 psi working pressure. Per ASME code, which these tanks are all built to code, the tank is designed and tested at 1.3 times that, so there's a safety factor built into the fabrication, the thickness of the steel, and the testing of the tank to ensure that it will work at 250 psi and still have that safety factor. On the top of the tank, there are two safety relief valves. There's one on this end and one towards the other end. Those are set at 250 psi, so those are additional safeties that if the system was to, say, a pump turned on and never turned off, if the pressure got up high enough, they would open up relief pressure off the tank to keep it from overpressurizing. The hydromatic tank is here for the sole purpose of regulating how often a pump turns on and off. And that is based on the fact that water does not compress. So if you had water in a pipeline and you opened a valve somewhere, the pressure would immediately drop to 0, the pump would turn on. As soon as you close the valve, the pressure would spike up, the pump would turn off. So to get around that, we have a tank that's partially filled with water, partially filled with air. The air is a compressible medium that we can calculate the rate at which it will expand and contract, which gives us a usable amount of water volume as water is used in the system. The water comes out of the tank, that air expands to fill that void, and that rate in which it expands and the pressure decreases, again, is calculable to determine how much usable water you have and how often the pump's going to turn on and off. Your tank, to get the most efficiency out of it, the water level is always going to be below the center of the tank down because the air is being used. I like to refer to it as like a battery. It stores the energy from the pumps. The hydromatic tank, the air compressors, none of that adds any pressure to your system. It is there solely to maintain the pressure that the pumps create. So you have some marks here. There are probes in this probe bottle tube that control the add or solenoid valve, which allows air from the air compressors to come into the tank. You have a mark here is where it starts adding air, and this is where it stops. And this is your ground reference.
So
that
rather
it's
than
reading to.
like a clear sight tube in the building or something where you kind of customarily see them, everything's mounted there on the
Everything's mounted here.
Okay.
And we
Sorry.
do that for multiple reasons.
We do have it on the HMI screen also that shows those.
Yeah, you will see on the HMI screen if the probes are activated or not. One nice thing about having it in a probe bottle off the side of the tank, you can always test your system. If you close the isolation valves at the top, at the bottom and the top, drain it all off. Guy knows. Close it. You can open this and you move that water level anywhere you want in that tank. That way you can test your probes, you can test all your other sensors, and you have a way of looking at your system to make sure everything's functional without having to take it out of service, because it can still be running during that entire process. Your system, I don't remember what they said it was, and I'm sure they'll go over that when they go over the controls. It's like 165 to 185 is what pressure range you're going to run. You have a mechanical pressure gauge here, which is going to tell you quick visual indication if you didn't have power for any reason. You have a pressure transmitter underneath that reads back to the control panel, which is looking at the system pressure. I cannot tell you what these devices are. We did not provide those.
Which
you
ones?
guys, the red light and
That's just
I
the
believe
warning.
That's the heat trace.
oh, that's heat trace.
Heat trace.
Okay.
That's gonna be your indication that it's operational,
Ah,
and that's
oh,
your
yeah.
spice box.
I see the heat trace here now. Okay. So that's going to keep it from freezing in the winter, obviously. I would suggest this sight glass is here just as a manual indication. If you come up, you can take a quick look and see, yes, it's within the proper range. In the winter, obviously when it's going to freeze, close these valves, top and bottom, and drain it. I get calls every year that the glass
My
is
glass
broken.
broke.
Exactly. Because this has nothing to do with the operation of the system. This is just so you can walk up and go, yep, that looks good.
Can they heat trace that also?
They can. It is heat traceable. On the other end of the tank, you have a manway. That's your access in and out of the tank. By most codes, it's required to take the tank out of service every 5 years. Go inside. You can lightly pressure wash it. Main thing is doing an inspection of the interior coatings. Make sure there's no cracks, flaking off of it. If there is any, get it repaired. If you do that, this tank will last forever, because the only reason they fail is from corrosion.
Yeah.
And again, as I said, because there is air in contact with water, there's always going to be some loss of air through attrition, which is where the air gets absorbed into the water. So that water level is always going to want to rise up. That's why we have the air compressor, so that if it gets too high, we add it, bring it back down, so we maintain that correct air to water balance for your pumping system.
How many controls do we have for total that are in that?
There's 3 probes in this
I
one.
was going to say site 2, but that's not going to work.
There's
Probe
three.
bottle. There's three. There's the add air start, the stop, and the ground reference. So in this one, there's only 3.
There are going to be more on the upper one.
So when it calls for air here, will it call for them simultaneously? They'll call for them simultaneously?
It
Or it's
opens
just
the
gonna depend
solenoid
on-
valve, so it's whichever one is, and more than likely, when it calls for air, air's going to come out of both those receiver tanks. They're both going to turn on and on.
Right.
The piping is coming from the skid to here, goes in the tank. This bypass is turned off normally. The water goes out here, goes in that pipe, goes back in the building, and the only reason it goes in there is because there's a flow meter.
Right.
Yeah.
So it goes loop. So this valve is normally closed, the one you got your hand on. These valves are normally open.
Engineered to test the coefficiency of that pipe.
Yeah.
This the only transducer on the unit anywhere?
Yes, that's your discharge pressure. That's what controls the whole system in automatic. That's very important.
Yes.
Danny, why don't you go next?
Okay.
Is there, well, I guess we have to do the air compressors.
Yeah. One more here.
Yeah.
Let's do the air compressors and Danny go next.
right here.
compressors. You got one in each corner. They are Curtis Master Line. They are a splash lubricated machine, 5 horsepower, 480 volt. You have a pressure switch. This is what turns them on and off. It's a standard pressure switch. Clockwise increases pressure, counterclockwise decreases pressure. They're currently set to turn on at around 170 and off at 190. And that's based on your system pressures you're going to be running. This always needs to be at a higher pressure to be able to push air out to your surge tank. On the top of the unit, you have an intake air filter. The intake air filter should be taken off. I typically recommend in the very beginning, maybe once a week. You can blow it off, clean it off, and then replace it. If you wash it, you obviously need to make sure it's dry before you put it back on. Once the room gets clean and doors are shut, you can probably change this to once a month, every couple months, and that'll be kind of something you guys need to look at as far as how often you need to clean that filter. You have an oil level gauge here. The oil level, it's hard to see here because it's darker, but it's going to be up near the top, just below the top of this glass. You have a fill cap that's red on this other side, and then your drain tube is here for draining the oil to replace it. You do have a low oil level switch. If the oil level goes low, there's a float in this box that will drop down, and it will kick off your air compressor and give you an alarm that the oil level is low. You shouldn't have too much of a problem with this on your system because you have a fairly wide gap between the add air and stop add air. But if these compressors don't run for long lengths of time, they can condensate inside the heads, which will drip down into the oil. If the oil starts to get cloudy, don't be foamy, then it needs to be replaced immediately. That is one thing that will void the warranty on these. This first break-in oil should be changed after about the first month, and then you can go by the O&M manual. There's an hour meter on the control panel, which will tell you how many hours are on each unit, so that you can base your maintenance on that. You have a receiver tank, a pressure gauge, which is reading the pressure in the receiver tank. These are pretty much self-contained units, so they are going to pressurize their receiver tank and stop at that point until it's called for air.
Okay.
This solenoid valve is an unload solenoid valve. That is normally open, so when the compressor's off, the solenoid is open. It takes pressure off of the heads so that the units start not under a load. There is a manual valve under the tank. It's like you would see on your little air compressor at home.
Mm-hmm. About once a month? Or
About once a month, I would open that up, lead off whatever water has accumulated in there. You do that, it's going to help extend the life of the air compressor. Again, your control panel, you have a handoff auto switch. It's always going to be normally in the auto position, off if you don't want to run it. And hand mode should only be used more like a jog. It's just for testing. If you put it in hand mode, it takes the air pressure switch out, so this unit will run until it blows the safety release off. Again, you have your compressor overload, low oil level, failed to start, and you run light. Then you have an emergency stop on the outside if you needed to kill it for any reason. One of the main things that I like about these control panels in this company, all your drawings are right here on the door with the bill of materials, so you know everything that's in this unit. So if you have anything failed, you can come right to this list without having to go to a manual or anything else and look it up and see what parts you need. You do in this unit have a surge protector. As long as all 3 green lights are on, you have good surge protection. And you have a phase monitor, so if you lost a phase or something went out of phase, that it would shut the control system down so it wouldn't run.
Get a few of these
hang on to.
Yeah, a few relays are not ever a bad thing to have around. Any questions on any of this?
So far, no, sir.
Pretty simple. That's my stuff.
Yeah, I had one question. It was on your lesson plan. So when they say they got to drain the tank, how do they? How do they start it back up?
To start the tank back up after you've taken it out of service, you're going to put the water level up to where the add air is, that mark on there, and then you're just going to open up your solenoid valve for adding air, and I should have pointed that out, is over here in this piping. There's a bypass ball valve at the top of it. Open that bypass ball valve and pressurize the tank up to 185, which is the pump shut off, and then you're back operational. You also have 2 air filters over there. One's a particulate filter, the other's a coalescing filter to take whatever oil carryover might be from the air compressors and take it out of the air before it gets to your hydro tank. These compressors are filled with a food grade synthetic oil. So that also helps protect your potable water system from any contamination and the fact that it's food grade oil. And then you've got the 2 filters.
Is that the only other solenoid on the?
That is the only solenoid in this system. That is the add air. It will open up. The airline piping comes from both tanks to the end where the filter is down there, and then goes up across. It goes through that regulator, but that regulator, because we have to have the maximum amount of air capacity out of these tanks, that regulator is pretty much open wide open.
Okay.
It's not being used. It's just there. The only thing it's good for is it'll give you a pressure reading if you needed to see it,
Right.
and didn't want to look at the ones that are on these tanks.
Not too many moving parts.
No. We try to keep it simple.
All right, Danny.
Alright, I'm next. So this is a control panel that will control the process of this hydro-pneumatic system. On this first screen we have a saddle system overview. Pretty much gives you the whole process in one screen here. We have the 2 tank levels, which is tank 3 and 4. We have the flow meters, which is, we have 2 flow meters here. We have a discharge flow meter and a chlorine feed flow meter. We have statuses for the chlorinator also here. Red means off, green means on, yellow means there's a fault condition. In this section we have the 4 booster pumps, which you see on your back side. We have the 2 compressors here. Compressor 1, compressor 2, and then their generator status. The only thing that we're going to get on the generator is run, that will turn green, or if there's a common alarm, will turn yellow. Red means off. We have a little picture here for a hydro pneumatic tank. We have 2 indications, which is the 2 probes. We have the add air on top. The middle one is to close the solenoid. And then the bottom one is just there's water in there. It's just a picture in there. We have a discharge pressure. This is the one that's very important. And I'll tell you why when I go into the other screen.
That's monitoring that transducer on the bottom out there.
Correct. That's the one right there. We have, here's our solenoid, which they were talking about a minute ago. That's your solenoid will go on and off. Green is on right now. So it's open to add air to the tank. So right now we have 174 PSI.
And it'll show fault yellows if the solenoid had a problem or something?
It will show just to, and this one will only show
Just
two.
operator.
On and off.
Okay.
Yeah. And then here we have analyzers. We have 1 and 2. So we have one before and we have one after on the discharge side. So there's your indication right now at 0.7 parts per million. Here we have 0.5 parts per million because we're not using it yet. But it should be higher than that once we get it operational. This screen is very important. This is your main hand-off auto to operate the system. When you have an automatic, the system will take over. When you have it on off, of course, nothing will work. When you have it on hand mode, you physically have to go to each and start it yourself. The operator will take over. The system will no longer take over it. So you will go to each individual and start it as many pumps you want. Same thing on the chlorinators are standalone. That runs. I mean, the compressor runs by itself. Yeah, there's nothing there. That's why they won't take it to a screen. Also, here's a screen for the hydro tank and operating the solenoid, so you can open and close it. There you go.
Sure.
And hand mode. That will only work in hand mode. That's about it. Everything else, there's no hand operational other than a standalone system. This indication means that there's no alarm present. When there's one, it'll show red and alarm on there. So that's a visual for the operator. Hey, there's an alarm. We also have a beacon slash buzzer out there. It's very loud in case of an alarm. You're gonna hear all the way to Fort Davis.
Well, when that goes into alarm, that normal button, is there like a, when you press that, does it give you a drop
No, it's
down
just an
screen?
indicator.
So it's just an indicator.
Yeah,
okay.
you will go to alarms.
Okay, I
and
see.
here's your alarm page.
Perfect.
So we have a couple of them right now. There's 3 that got stored in there. Air compressor 1 fault, which will be that compressor over there. But it will tell you the time, the date, and it will store it in there unless you go in there and select it, and you can erase it. But if not, you can leave it alone. Blue means that it's been acknowledged. Red means it's active. So if you see highlighted red, it means that the problem still exists.
And the only way to acknowledge these currently is to come in here physically.
Yes, it's
and-
gonna. Any alarm will be active, and then it's gonna sound your buzzer and your beacon light, and then the operator will need to come here and press alarm reset, and then fix the problem. So that's very simple alarm page. On every 4 to 20 signal, like a level, analyzers, flows, they do have trending. So you'll press the tag 3, and then it'll show trends, and then we'll put here these little squares right here. If you want to go a particular year, month, day, hour, minute, seconds, up to the seconds, you just put whatever you want to look for. You press it in there, and then you press the whole button, and it'll take you there. If you don't want to mess with this, you just scroll back and forth. Right now, we just download the program, so give it some time to store some data.
Yeah,
So, for example, I will put here 2021 07 day. Let's go to the 25th. It's not gonna show me data, but this is the way it will show it. And then the hour, it goes by 24 hours. So I will put 21 there, and then press hold, and it'll take you to that
yeah. No, okay.
that timeline. But for now, I don't have enough sufficient information yet. You gotta let it pass for a couple of days. So that will happen on each level indication or flow indication. It has that feature. Here's your flows. Here's chlorinator, right here, analyzers. So I have them both side by side. So you have your before and your after.
And it works exactly the same way to access
Exactly.
the trends.
But since it works in pairs, so you would put the time, it'll take you on both trends
All right.
at that time.
Good deal.
There's also this pressure. Here's a pressure indication. Same thing. Flow, same thing. Analyzer. It's the same screen, but I just have it on the bone. Either or analyzer. Now the important one, system settings. This is very important because this is what controls your system in automatic. We gotta make sure how you want your pumps to operate. Lead means the first pump will turn on this pressure. So we have it right now at 160. The second one 120. Third one at 115. The lag 3 will be at 110, but those can be changed, which is what we're just testing right now with those values. And then all pump will shut down on this stop set point, 175 psi. So this is very important when you want to run your system before you put in automatic. Make sure all those are the way you guys want them to run. On the alarm chlorine, this section and this section is just to alarm you. So right here on your first analyzer, you have a high chlorine and you have a low. So that's depending on what you guys want to put on there. Same thing on this one, the second chlorine analyzer. And then this section will be your high tank level, your low tank level. And then discharge pressure, what you want it to be your minimum, what you want it to be your maximum. I have it at 195. This tank, like you said, it can go up to 250 max, and then it will open the mechanical bleeders. We have flow also, high and a low. I just have it at 1500 for now. It's your choice how you want to put it, for both for the feed and for the discharge. This is very important also. That will trigger your fire enable. In case of a fire, what GPM you want it to trigger. So this, if you want it to be lower, you can put it 500 GPM, and as soon as it sees 500 GPM, it's going to trigger all the pumps, or as many pumps to turn on at the same time. Well, not at the same time. It's going to stagger them at least a second for each to turn on. But that will trigger for emergency, where you need to put out a fire. Any question on this screen? Very simple. And that's pretty much it on the screen. I want to show you the inside. On the inside of the control panel, we have our main processor, which is the Allen Bradley Compact Logics. That's the brains for the whole setup. We have our relays. That's the outputs for valves, pump starts, the beacon light, the cylinder valve that we have for to add air. This section, this is your probes. This is your probe relays. We have a surge protection for 120. We have this is a filter for dirty power, so it has to go through here before it goes to my system. Receptacle for laptop use only. We have power supply redundant, so if this fails, the dial will trigger to the next second backup, or vice versa, back and forth, depending which is primary. In this section, we have our main circuit breaker, which is your 120 volt AC, which is being supplied by the UPS. We have our sections of fuse for every device that have a 120 hook up to it. We do have secondary fuse for more protection on it. Your neutral and your ground. This is your 120 AC. This is your plus and minus 24 volt DC bus. Again, we have a main circuit breaker, and then we have secondary fuse for more protection to your devices. And then after that, we have your digital inputs section. We also fuse them for more protection. Individual, these are all fused. You can take one at a time. You can find this one. It pops out. You open this guy up, and then you replace the fuse. So we have our discrete input, discrete outputs. All these are from here. It goes from the output of the PLC to this terminal block, protection, and then from there it goes to our relay, solid state relays. And then this section, it's all your analog input, and then this is your analog output. So they're also fused. These are all your full 20 milliamp signals, and that's pretty much. And then your HMI. And then we have all this information in case we don't know the IP addresses or anything. I put it on there. We are 508 UL certified, so we put our information on there. And then our schematics are there. We're gonna update them for you, redline them, and then we'll put a fresh copy there once we're done with this project. And then for your conduit work, in case you don't know where your wires are leading, we'll put labels on there where everything is going to. And any questions? If not, we'll go and turn it to Mark Snyder.
You guys got another 15 minutes? Is that good?
You okay for another 15 minutes?
Okay.
Okay, so I told you about the tank, I told you about the controls. So basically what we're trying to do, the game here is to keep the tank about half, or whatever it was, a third to 40% full of water, and then keep the air on it. That's the game. And then also keep pressure, to the system. Like he told you, everything's running off that pressure gauge out there, the electric pressure transmitter. But there's one that needs cleaned off a little bit. One right here. When you're standing here, you can see it's 175, or it should match that. What do you got over there, Dan? What do you got pressure?
174, 173.4.
So we'll clean it off a little bit. Anyway, so the water's coming in again from the back. It's coming forward, going that way, going to the tank, in the tank, coming out, going through the flow meter, going out that pipe, going straight out that road, goes up the hill or down, or the other hill. That's And then, we got to keep water in the tank, so we'll do that. We'll do that training, but we got valves in there for keeping the tanks full. And you can shut down on low level alarm if they run out of water. Have you done that?
The high level on the tanks?
On a low level.
Low level?
Yeah.
Yes, it does have a low level
Shutdown.
shutdown on the
Okay.
pumps. So it
Okay.
won't run dry.
Wherever we set those set points. is
Correct.
where they would-
Yeah,
That
so
is
it'll
correct.
shut me down over here.
Yes.
Okay. So over here's a basic lineup. Got your soft start. Here's your suction. Here's your suction valve. They're gonna stay open. Your string fitted in case you want to remove. Makes it easy to pull stuff in and out. Got your pump. Got your motor, and got your. Here is your. Look on this side. This is your coupling. And see how I can spin it by hand. It's in automatic. I shouldn't do that, but anyway, it should spin easily. Okay, to replace the seal, if you ever get water coming out of here, you'll undo this coupling from the motor, and you'll see that the shafts are about that far apart from each other.
Is there
Okay.
any tightening tensioners on that? Or?
Yeah. So what you're going to do is, James, hey James, can you tell him how to replace the seal?
With these big motors,
Let me turn it off.
you're
Let me
just
turn it
gonna
off.
unbolt this coupling right here, and there should be enough space in here where you don't have to pull the motor. And so you just unbolt these. This is your 4 screws holding your housing down. That's your gap that you want to set your seal
Okay.
at. So when you take these 4 bolts off, you're going to take this plate off, and then the seal is right there. And it just, if it's a little tight, 2 screwdrivers. I use 2 little screwdrivers. Pull it straight up. They're so user friendly. I love this style
Awesome.
of pumps too.
And then show them the rotation.
The rotation marks right there. And then if you do usage, you got to replace the whole pump. You just buy a stack kit. Now some people will try to rebuild them, but we've never had any luck at it,
Yeah.
especially the cost of the stack kit.
Man, no kidding.
You take that you have to remove the motor. Take these 4 bolts out, undo this, and I always tell them to put a new seal, even if it's not leaking, because now you're taking out, putting a new stack kit with an old seal. To me, you're asking for trouble down
Sure.
the line. So you get a new seal, you get a new stack kit, you take the motor off, take this part off, take the stack kit out, put it in, rebuild it. Some of the smaller ones I can do in an hour.
Yeah, that's not too bad, huh?
No, it's not. They're very user friendly, and the biggest problem for these is air.
Yeah.
So if you ever
And
think
nothing
you,
for me to over tighten and mess up out here either.
especially if you have this in there, it'll stop you. Now, with another style of pump we sell, the gap is a little smaller, and I always, as I'm putting it back together, I keep spinning it, to make sure I'm not getting no drag, because there's been times where I've used that spacer, and I still could feel some drag.
Yeah.
So then you kind of just got to go in there and get it up to where you have no drag, and then see what your flow is.
Yeah.
But normally it's not even that noticeable. If you go out of what your,
Yeah, yeah.
piece of plastic that's made in a machine that's supposed to be a critical setting
Yeah.
doesn't work right,
Yeah.
and
But that never happens.
your 2 little screwdrivers work better. But yeah, for servicing these are so easy. But water is, and then you just bleed your water off right here. Might wet you. I don't know which way
It's a good
so
spot
you don't
for a
get
sampler.
no water piss off. Just a stream of water. And if you ever suspect introducing air, it takes nothing to bleed the air.
Just make
off
sure.
those. Did you talk about the purge valves too,
No,
Mark?
go ahead.
These are temperature rated purge valves. So if somebody deadheads the pump and the pump starts to get hot, that's going to pop off.
Okay.
So if you ever see them dripping, it could be going bad. It could have debris in it. And I don't know if they're rebuildable.
They're
Yeah.
cheap enough. You can just
Yeah.
They're like $100.
Wear out them, replacement out them.
And very rarely I've seen them go bad. I've seen them work when they needed to work, and then once you put everything back to normal, they'll close back on you. But they'll wear out.
How often do the grease zerks on these motors need to be?
Depending on how much you use them, but twice a year max. 2 squirts.
Right, it's not a hell of a
Yeah,
lot.
not a lot.
And that's what I was looking too. So you do have on this one, when you grease this side, pull this plug so you don't over grease it. but I couldn't find the one on the top. You may have to take that off. to get
Okay.
the one on the
It's
top.
not this one?
No, that's the grease cert, but there's not one on the other side.
Yeah, I don't see one.
I wouldn't do it. I wouldn't overdo it.
Yeah.
And then this is your your air release. You know, and they're not going to work a lot once you're in operation. This is a surge buster check valve. This is to control the closing speed. So right now we're okay. That's gonna. It's like a clay valve almost. If
Right.
you're going PRVs.
Without the solenoids and stuff.
Yeah, it's
on
got
there.
the. It's just got a little spring in it. Locking nut. So down is faster, and then lock it back down.
Man, those turbo grip hands of yours.
So
I'll
that's
tell
what
you.
okay now. So we got your check
He's trying to
valve,
make me
you
look
got your
bad.
isolation valve, and then you know which way the pump goes. You got your mechanical perch, and then the only thing left is this soft start. And then, and I'm sure you don't want to go inside, but I know I don't. But you know, it's just we've set it all up. The only thing you'd ever get in there for maybe is reset. Maybe that's the only reason you ever get in there.
And then probably my cycling towel would be the best one.
Yeah. But what we did is it didn't come like this, but we added a different HOA. So now when we put it in a remote, it shows up over there.
Oh, okay.
And when you take it off, it says it's not an auto. I don't really like this hand button because these pumps generate 360 feet of pressure. And so I don't really like running them in hand.
Yeah.
Anyway, they're in remote. And then if you ever need to, you got hand. You know, if you need to. I think you probably have to hit that start button.
Yeah. They just
Anyway, so
moved
they're
it off the side and put it on the front.
So they're here, they got emergency stop, you know. So if you ever got into a situation where you had to run it in hand, so what you do is you'd have to stay here and just use one pump.
I was gonna say you probably.
You can't even walk off because it generates so much pressure. And then you send a guy in the back and make sure the water's right where it needs to be.
Monitor it.
And then take the air valves. I mean, it'd be a pretty big deal. But if you want, I'm gonna go open up a valve and you guys watch it come on.
The other thing, if one pump is out of service, you leave this off, and my system will skip this one and alternate to the next one. Automate alternate this.
So I'm gonna go.
The main breaker for each individual pump on this panel,
Okay, I understand.
and then the main breaker for this panel is this one. So these are the compressors. The electrician's supposed to tag them, and this is the main breaker for that panel. And then you have individual breakers, so if you had to work on one, you know, there's your disconnect. And for some reason, they put a 2-pole 15 in there for, I don't know.
These are the main breakers for each pump. Pump 1, pump 2, pump 3, pump 4, and most likely a spare. Is that a spare,
Sorry.
James? That's
Yeah, it's a
okay.
2-pole 15. I don't know what it's there for.
Let me go turn it on. You guys can see 2 cycles.